Hi, this is Presh Talwalkar. In the previous video, I asked you, what's the expected number of rolls until a die shows a duplicate number? In this video, I'll present the solution. The answer is it takes about 3.77 rolls for a die to show the duplicate number. Let's see how we'd get to that answer. We'll think about the question in reverse. Imagine you've already seen a die that shows all 6 different numbers. How many more rolls are needed until you repeat one of the numbers you've already seen? We've already solved this question. Obviously, on the very next roll, you're going to see one of the 6 numbers because there's no other choice. If you've seen the numbers 1 through 6, the next roll will necessarily show one of those same numbers again. But we're going to put this in a little bit of notation. Let's write e of x to equal the number of rolls needed if you've already seen x numbers. So we've solved that e of 6 is equal to 1. So let's work on this. What happens if you've only seen 5 of the numbers? How many more rolls until you see a repeat? We want to solve for e of 5. And we can do this based on knowing e of 6. It's a recursive formula. So what is e of 5? There are 2 different things that can happen. One thing that could happen is we might roll one of the 5 numbers we've already seen. That's kind of what we want. So what's the chance that we're going to roll one of the numbers we've already seen? Well, there's a 5/6 chance of that. Because we've already seen 5 numbers out of 6, there's a 5/6 chance that it'll take exactly 1 roll until we see a duplicate number. But there's the 1/6 possibility that we get one of the numbers we haven't seen. In that case, on that next roll, we go to the state of having seen all 6 numbers. And then the average time it will take for us to see a repeat is e of 6. So we've set up an expression for e of 5 in terms of e of 6. And the great part is, we've already solved that e of 6 is equal to 1. So we can substitute that, and we get e of 5 is equal to 5/6 plus 1/6 times 2. Which means e of 5 is 7/6. If we've seen 5 of the numbers, it will take us 7/6 rolls to see a duplicate number. And this makes sense. Almost certainly, most of the time we're going to see duplicate number on the next roll, but on occasion we get that 6 new number, and then we're certain to see it on the next roll. So let's repeat this process. What happens if you've seen 4 numbers? How many more rolls are needed until you see a repeat? We'll set up a very similar expression for e of 4. There's a 4/6 chance that we'll repeat one of the numbers, and that very next roll will give us a repeat number. But there's also a 2/6 chance that we're going to get a new number. And now, if we get a new number from having seen 4 numbers, that'll bring us to the state of having seen 5 numbers. So at that point, the expected number of rolls will be 1 plus e of 5. Since we've solved that e of 5 is 7/6, we can substitute that in, and we can solve that e of 4 is 25/18. And now we repeat this process. If you've seen 3 numbers, how many more rolls until you need a repeat? We just need to change the numerators and the final term that we go to the state of having seen 4 numbers. So now there's a 3/6 chance we repeat a number, and there's a 3/6 chance that we get a new number, in which case we would go to the state of having seen 4 numbers. Since we know what e of 4 is, we can substitute that and solve that e of 3 is 61/36. Now we can repeat this process for 2 numbers. We'll solve e of 2 for 1 number, solving for e of 1. And finally, we go back to the beginning. If you've seen 0 numbers at the very start, how many rolls are needed until you see a repeat? And that's our answer. 1223/324, which is about 3.77. So it takes nearly 4 rolls for a die to see a duplicate number. Thanks for watching this video. Please subscribe to my channel. I make videos on math and game theory. You can catch me on my blog, Mind Your Decisions, which you can follow on Facebook, Google+, and Patreon. You can catch me on social media at Presh Talwalkar. And if you like this video, please check out my books. I provide a description of each one in the video description.